Good evening, ma'am. My name is K. Pranavi. My roll number is 234G1A0488. I am from ECB section, and my topic from DEVC is Green's theorem. So let us see. So what is the Green's theorem? The Green's theorem is a fundamental principle in vector calculus linking the circulation of a vector field around the closed surface to the flux of the fluid across an open surface bounded by the curve. So mathematically speaking, the Green's theorem is actually defined as the equivalence between a line integral closed a around a closed curve and a double integral over the region enclosed by the curve. So let us see what is this theorem applications in physics. Like this theorem can be used in physics in such a cases that as a electromagnetism, fluid dynamics, where we can use them in the two-dimensional space and vector fields. Then we'll get the answer by applying this Green's theorem. So let us see what is the statements of this Green theorem. So integral of the curved region mdx plus ndy equals to double integration of the region of dou n by dou x minus dou m by dou y into dou a. Dou a is nothing but dx by dy. So let us see what is the question given for us in this Green's theorem. So verify Green's theorem in plane for integration C of 3x square minus 8y square into dx plus 4y minus 6xy into dy, where C is the region bounded by y equals to root x plus y equals to x squared. Given the limits of the y, and we have to find what are the limits of the x, which we'll see in the next slide. So let us say, according to the equation, we'll know that m equals to 3x square minus 8y square, n equals to 4y minus 6xy. By applying the partial integration for m with respect to y and for n with respect to x, we'll get the values minus 16y, and for the n, we'll get the value minus 6y. So dou n minus dou x minus dou x minus dou m by dou y equals to minus 6, which give the answer 10y. So as we know that to verify the Green's theorem, we have to find out LH equals to RHS. So let us see the LHS first. So integration C 3x square minus 8y square into dx plus 4y plus minus 6xy into dy equals to double integration R 10y dx dy. So let us see from the LHS, we'll get the we'll draw the diagram of both m and y. Then we'll get a same region for that is OA. So as we know that OA to AO. So there are two regions. So we apply the two regions in LHS. So according to the OA, the limits are x of x equals to 0 to 1 and y equals to x square. We do the differentiation to y and we'll substitute the in y place, we'll substitute these values. So along OA, we'll get integration x equals to 0 to 1, 3x square minus 8 into x square into dx plus 4 into x square minus 6x square into x. So by solving this equation, we'll get the integration x equals to 0 to 1, 3x square plus 8x cube minus 20x per 4 into dx. Now applying the integration and limits to the equation, we'll get the value minus 5 by 5, that is equals to 1. So now as we found out AOA, now we're doing the AO. So in the AO, the limits of x are 1 to 0 and y is root x. Now differentiating this, we'll get the value 1 by 2 root x into dx. Now applying these y and ay values into the equation, we'll get the equation integration x equals to 1 to 0, x 3x square minus 8x into dx plus 4 root x minus 6x into root x into 1 by 2 root x into dx. Now applying the doing the calculation between them, will get finally the equation 3x square minus 11x plus 2 into dx. Now applying the integration and the limits to this equation, will get the value of 5 by 2. So now as we know that OA integration along OA plus AO equals to minus 1 plus 5 by 2 equals to 3 by 2. Value of LHS is 3 by 2. Now, coming to the RHS, we know that double integration R into dou n by dou x minus dou m by dou y into dou dx into dy. Now, substituting the 10y value into the dou n by dou x minus dou m by dou n and applying the limits x equals to 0 to 1 to y equals to x square into root x. Now we are doing the calculation for the y integration to the. Now, as we see, 10y square by 2 into limits applying x square into root x. Now, the equation gives 5 into 5 integration x equals to 0 to 1 root x square root x whole square minus x square whole square, that is into dx. As we apply the limits and everything, we'll finally get the value of 5 integration x equals to 0 to 1 to x minus x power 4 into dx. Now applying the x integration and values limits to this equation, we'll finally get the answer 3 by 2, that is RHS. As we know that to verify the Green's theorem, the LHS and RHS should be equal. Now 3 by 2 equals to 3 by 2. Hence the Green's theorem is verified. Thank you.